Today, me and Aiden will be teaching you the inelastic deviation. In an inelastic collision, there are two constants. The momentum, which is the same before collision and after collision, and the kinetic energy, which is the same before and after the collision.
As you can see here, there are two objects that have the same momentum combined before and after the collision. And as you can see here, there are two objects that, when combined, have the same total kinetic energy before and after the collision.
Using the equation for momentum, I substituted the equation in for each instance where the momentum is found in each object before and after the collision. For the kinetic energy, I substituted the kinetic energy equation for each object in each instance before and after the collision.
Each term in the kinetic energy equation has 1/2 in it, which then means you can cancel out all the 1/2s in the equation.
The next step for the momentum equation is to make both sides of the equation have like terms. So from here, it'll be easier to
The
simplify.
same can be done in the kinetic energy equation.
After putting the like terms on both sides of the equation for the momentum, you can factor on this side m1 and this side m2. For the kinetic equation, you can factor out as the same as the first, m1 and m2.
By dividing v1 and v1 prime from both sides, you can then find the value of m1.
Now that we have the value for m1, we can input this equation into this equation by substituting it for m1. As now the m2 is put into this side, we can cross out the m2 on both sides as they cancel out as they're on both sides of the equation.
By multiplying v1 minus v1 prime to both sides, it then grants you this new equation.
As these two terms are both squared, you can simplify them to create now the v1 minus v1 prime and v1 plus v1 prime, and on this side with the v2 prime minus v2 and the v2 prime plus v2.
As you can see, v2 prime minus v2 is on both sides of the equation, as is v1 minus v1 prime. With that, you can then cancel out both of these terms on both sides.
The final equation comes out to be v1 plus v1 prime equals v2 plus v2 prime. Ta-da!
Let's go! Yeah!
The equation we'll be using is the inelastic deviation, as was said earlier. We will alter this equation so that we can find the variable vb prime, which is the only unknown variable that we do not know.
This is the givens and unknowns of the problem. We have VA, VA prime, VB, and V prime ranging at 10, 5, and 8. And with these variables, we can then use this equation.
Now we will use the inelastic equation deviation in a real physics equation to show you how it can be used. In this situation, there are two objects going in the same direction which end up colliding. After the collision, they'll end up going in the same direction.
Boom! Take the equation. Boom! Right there. You take this one. Yep, you see it. You subtract VB from it. So then you can get VB prime alone.
With this equation, I substituted all the values. For VA, I substituted 10. VA prime, I substituted 8. And then for VB, I substituted 5.
When you simplify the equation, you then get 13 meters per second.
Our problem is correct. We checked it using the inelastic derivation. I inputted the values for VA, which is 10, VA prime, which is 8, VB, which is 5, and VB prime, which is 13. They both came out to be 18, which means our problem is correct.